Hi guys, it's the educator here. Welcome back to my channel. So just like I have promised, I said I'm going to be dropping a video on compilation of JAMB 2026 chemistry video, chemistry questions, and this is the video. Okay, so you can either make use of this video to practice or then use it to just have an idea of how JAMB 2026 chemistry questions have been coming out. Okay, now one thing you should take note of is that the purpose of this video is not to show you exactly what you are going to come across in your examination. Okay, so just like I said previously, that it is number one for practice. Okay, so you can either use this video to practice, especially those who still have their exam probably in a daytime or 2 days time, or use it to have an idea of concepts that have been coming out in UTME 2026. Okay, so this video is a compilation of day 1, day 2, and parts of day 3. Okay, this video is divided into two because I am still making a compilation of the second part. Alright, so in this video we are going to treat 50 questions. Alright, so let's get started. So the first question here is, which of the following is an example of an aliphatic hydrocarbon? Alright, now there was a particular comment I saw recently on one of the videos I dropped, that is as regards UTME question 2020, and someone was like, these questions are too simple for UTME. Okay, now I don't really know the kind of orientation that some of you have gotten or what you have heard, but trust me, I can tell you that for free, that UTME is as simple as any examination that you can prepare for. In fact, UTME is even more easier compared to your WAEC, NECO, and GCE. UTME is way more simpler than those other examinations. So if your mindset is what I'm going to experience that day is going to be questions that are coming from heaven or questions that are coming from hell, just remove that from your mind, because having that mindset alone can just destabilize you. And then even when you get to the examination hall, if you see simple questions, you end up failing it. Why? Because you just felt that, oh, simple questions will not come out, so let me prepare for the hard one. And then you go the other day and you meet simple questions and you not be able to attempt it. So as much as possible, all these questions that will be treated today, you should ensure that you have an idea. All these things is just make sure that, oh, in case you come across it, because there's every tendency that you can come across some of these questions here. Okay, you can come across these questions. All right, different locations. I am currently recording this video from Delta State. Somebody watching this video from Kano State can see this question. Okay, so it's something that you should take note of and believe that it can come out. All right, take note. I am not saying it will come out, but then you should practice and learn it and see, oh, if I see it, I should be able to attempt the questions. All right, so now for question one, which of the following is an example of an aliphatic hydrocarbon? All right, so this is a very simple question. When you hear aliphatic, when we talk about hydrocarbons, we have basically two classes of hydrocarbon. We have aliphatic and then we have aromatic. Okay, so when we talk about aromatic are the benzene-like structures, right? The benzene-like structure. So when you see any structure looking like this, just know that this is aromatic, right? Irrespective of whatsoever constituent is added to it. So if I decide to add OH here, I will have phenol, right? So irrespective of the substituent that is added to the benzene ring, all of them are classified as aromatic. Why? All those other hydrocarbons that are not aromatic are regarded as aliphatic. So they can either be straight chain. So when you see all those your structures like this, either straight chain, or they can be branched, right? Or they can be branched. All these are classified as aliphatic. So if you look at the option of phenol, this is phenol. This is the diagram of phenol. This is phenol here already. So phenol is aromatic, toluene is aromatic, and benzene is also aromatic. So the aliphatic is ethane. Okay, a very simple question. And one thing you should take note of is some of these questions can be paraphrased, can be rephrased. I keep on saying it. Okay, I keep on saying it. JAMB questions are not new. JAMB questions are not new. One of the secrets to doing so well in JAMB is practicing a lot of questions. Just keep on practicing a lot of questions. If you are watching this video and your exam is like a day, 2 days, 3 days, please, what you need to do this period is to practice a lot of questions. Keep on revising. And how do you revise this period? Revise with questions. UTME questions are not new. They are old questions. Either they are paraphrased or they are repeated word for word. So the more you practice these questions, the more the question you see that they look familiar to you. Okay. Question two, the gas law, which states that volume. So we already have an idea of the question. The question is talking about gas law, right? Which states that the volume of a given mass of gas is directly proportional to the absolute temperature at constant pressure is. So when we talk about gas law, there are three things that majorly comes to mind. We have pressure, we have volume, and then we have temperature. PVT. This comes to mind. All right. Now, if you have P and V, there's a particular law that will come to your mind, which is Boyle's law, right? Boyle's law, which means that your temperature is kept constant. If you have volume and temperature, there's a particular law that comes to your mind, which is Charles' law, right? Now, if we have the three of them, there's a law that comes to your mind, which is the ideal gas law, right? Which involves the pressure, volume, and then the temperature. Okay, so now let's quickly look at what the question says. The question says volume, and the question says temperature. Meanwhile, pressure is constant, which means that this clearly shows us that Charles' law is the answer to this question. So you have Charles' law. Question 3. In a redox reaction, the substance that loses electron is said to be substance that loses electron. Now you should take note of the definition of oxidation and reduction. Okay, so when you have oxidation, let me say oxidation is O and then reduction is R. You should know the definition. Oxidation is loss of electron, all right, loss of electron, and reduction is gain of electron. This is one definition. You can define it based on hydrogen and you can define it based on oxygen. Oxygen, just remember the definition like this: oxygen. So for oxidation, you add oxygen. When you add oxygen, it is oxidation. Then hydrogen, the other one, will be removal of hydrogen. So when you remove hydrogen, it is still oxidation. The reduction is going to be the opposite. So you remove oxygen and then you add hydrogen. Okay, so now let's come back to the question. In a redox reaction, the substance that reduce electron is said to be. Since we already know that reduce or loss of electron is what? Oxidation. Okay, so the substance is going to be what? Oxidized. The substance is said to be oxidized because oxidation is loss of electrons. So question 4. The number of moles of solute present in 1 dm cube of the solution is called its correct answer is molarity. 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 So you either see molarity represented as 1 dm cube or you see it as 1 then capital letter M. Capital letter M. This M here represents dm cube. So you have molarity. You should take note, it is not molality. Okay, it is molarity. Alright, so molarity is moles of solute per dm cube of a solution. Okay, so the next question: which of the following is the characteristics of catalyst? Which of the following is the characteristics of catalyst? So we already know that catalysts are those substances that speed up reaction. Okay, and now you should know the way or the mechanism of action that catalyst uses to work. If we have an energy profile diagram like this, you should know your energy profile diagram. All right, I made a video on this. You can still remember. If you want to get the video, do well to check my channel for the videos I've created earlier. You will see it. So if you have an energy profile diagram just like this, and let me say this is, and then you have this line here, and they'll tell you this line is the activation energy. So you have activation energy for this particular reaction. And then now they now tell you that, oh, this reaction carries out, or in this reaction, the catalyst is added. In this reaction, when the catalyst is added, you see that there's going to be a change. The change will be something like this, and then like this. You will now see that the activation energy reduces. You can see the activation energy reduces. So one of the mechanism of action or how the catalyst works by speeding up reaction is to reduce the activation energy. So you should take note of that. All right. So why this catalyst is working to reduce the activation energy to speed up the reaction, it does not change. Okay, the catalyst does not change. So if the catalyst is blue, for example, if the catalyst is blue in color, at the end of the reaction, the catalyst is still going to be blue. The catalyst is not going to change. Okay. Now, let's look at the options. They said, which of the following is the characteristics of a catalyst? Number 1, it is used up in reaction. No, like I said, it remains unchanged. It is not used. B, it decreases the rate of reaction. No, I said it increases the rate of reaction. Okay. C, it lowers the activation energy. This is correct. It lowers the activation energy. It is through this process it speeds up the reaction. Take note of that. Okay. Question 6, the relative molecular mass of tetraoxosulfate 6 acid H2SO4 is okay. So just for the sake of, if you are preparing for UTME 2026, you should know how to solve RMM, relative molecular mass. Okay, and some compound relative molecular mass should be in your head. by now. If you are preparing for UTME 2026, it should just be there. Okay, so H2, H is 1, right? From the question we are given, H is 1, which means that this is going to be 2 plus, what is S? S is 32. That's 2 plus 32 plus O is 16, and 16 is, and O is 4. That's 16 times 4, right? And 16 times 4 is 64. So by the time we add this together, what are we going to get? We're going to get 98 gram. Our correct answer is 98. Okay. Question 7. Compounds with the same molecular formula but different structural formula are called, they have the same molecular formula. So we have same molecular formula, different structural formulas. They are called, this one is also a very simple question. These guys are called isomers. Alright, they are called isomers. So isomers share formula, but they differ in their structure. That's just what isomers are. You should know isomers is different from isotopes, and it's also different from allotropes. Okay, take note of that. Question 8. An example of a strong acid is H2SO4. H2SO4. I've done a video on this before. H2SO4. All right. In in a particular video, the first video I dropped as regards chemistry JAMB 2026 question, I dropped that video before UTME, and that video was just to predict JAMB 2026 question. And in that video, there was a particular question I explained that talks about strong acid. So you can see that the question is now coming out here again. Like I said earlier in the beginning of this video, all of these questions you are seeing here are questions that somebody, a student like you who has written UTME 2026, saw in their examination. So when we tell you that UTME is more of past questions, solve a lot of questions, it solves a lot of questions. Let me tell you something. There are a lot of questions. There are a lot of questions, are so much. Okay, so there's no way you are going to say you have solved all the questions on earth. There are a lot of questions. So the more you solve the questions, the more confident you are going to have for that examination. So you can see now this question is coming here again. And who knows, somebody is going to go and write this exam and then see a question like this. So one thing you should take note of is that the more you practice questions, the better for you. Okay, so try as much as possible to follow up. I'm also going to be dropping the second part of this video, all right, as soon as possible. I'm going to be dropping it. Also, I have dropped for biology, so if you are offering biology in your UTM, you can also do well to check it out. Okay, so I know the importance of questions, I know the importance of attempting questions. I have a special question bank. Okay, I have a special question bank for some topics. All right, so you can do well to, I've dropped the links in the description of this video. So just click the description of this video to access those links. So for physics, chemistry, biology, use of English, whatever subject that you'll be writing in UTM, just click it, access the question bank, solve as many as you can solve. Though the questions are not so much, so you can try as much as possible to cover everything. Okay, so let's continue. Question 9. The volume occupied by 1 mole of any gas at STP is 22.4 dmq. Please take note, it is 22.4 dmq. One thing that JAMB is going to be testing in UTME 2026, I said it when I made the physics video, is your patience and how well you can read and understand the question. A lot of persons will see this question. If you look at the options have a way of looking alike somehow. So if you're not patient enough to look at, oh, which one is actually the correct answer, you end up picking the wrong answer, thinking what you picked was right. So as much as possible, do well to shine your eyes, do well to concentrate, do well to focus while attempting questions that have this kind of funny options. All right. Atoms of the same element with the same atomic number but different mass numbers. This is known as isotopes. So we have defined isotopes now, and then we have also defined isomers. So isotopes differ in neutron number. So they can paraphrase the question and will tell you which of the following differs in neutron number. Just know it is isotopes. Then for isomers just differ in structure, but then they have the same formula. Okay. Question 11. The oxidation state of manganese in KMnO4 is. So how to calculate oxidation state is very, very simple. You know that potassium is 1. So now oxidation state of any compound is equivalent to 0. Equivalent to 0. So which means that, or if we add all the oxidation states of all the elements in this compound, we are meant to get 0. That is what it means. So potassium is +1, +1. Manganese, that's what we're looking for. So it's going to be X plus X, right? Oxygen is -2, -2. So that is going to be plus -2 times 4. That's plus minus 8, right? Minus 8. Okay, so now we are going to have 1 plus x minus 8. Okay, cancel this. Minus 8 will be equals to, so you don't get confused, let me just remove this. All right, so we have 1 minus 8, we have minus 7 plus x is equals to 0. So from here we already know the answer. So what's x? X is plus 7. So the oxidation state of manganese in this compound is plus 7. Number 12, which of the following is the functional group of alkanols? Alkanols, they are alcohols, okay, and they contain hydroxyl group, so it is OH. This represents alkanals. 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 This represents carboxylic acids. Carboxylic acids, and this represents alkanones, also known as ketone. So this is ketone. Option D, ketone. Option C, carboxylic acid. Option B, alkanols, and option C, alkanals. All right, so let's move to the next question. 13. A reaction in which heat is given out to the surrounding is a reaction where heat is given out to the surrounding. This is a very common question in thermodynamics. Okay, it is known as exothermic reaction. Take note of that, exothermic reaction. Then you know in endothermic reaction, heat is absorbed. That's just the difference. In exothermic, heat is released, then in endothermic, heat is absorbed. All right. So the next question: what is the mass of 0.5 moles of CaCO3, calcium carbonate? CaCO3. Now, the first thing to do when you see a question like this is to calculate for the RMM of CaCO3. Remember, we calculated for the RMM of H2SO4. So using that same method, if you calculate the RMM for CaCO3, you have that the RMM for CaCO3 is 100 gram, right? 100 gram. And now, this CaCO3 you are seeing here is also equivalent to 1 mole. So 1 mole is going to give us 100 gram, right? So the question says 0.5 moles will not give us what? So 0.5. But this is a very simple question. It's not something you stress yourself for. So if 1 mole is giving us 100, 0.5 will definitely give us 50. It's as simple as that. 1 mole is giving 100, 0.5 will give 50. Okay. Question 15. The pH of a neutral solution at 25 degrees Celsius is 7. Please take notes. Remember, 25 degrees Celsius is the standard temperature, right? You know we have S, T, and P. 25 degrees is standard what temperature. Okay, don't allow it to confuse you because they can put a tricky question. This temperature has nothing to do with this question, but then it's just there to confuse you. Once you see pH of a neutral solution, pH of neutral solution is 7. Remember your pH scale. Your pH scale is from 0 to what? 14, right? And then you have 7 in the middle. Okay, so this point here is neutral. Neutral. Okay, so from neutral or from 7.1 to 14, you have them to be basic. From 6.9 downward, you have it to be what? Acidic. Okay, take note of that. So next question: which type of bond is formed by sharing of electrons between two atoms? Remember the two basic type of bond. We have electrovalent bond, and then we have covalent bond. Okay, the electrovalent bond is also known as ionic bond. Ionic bond. In ionic bond, they transfer electron. So there is something that you should take note when you see sharing of electrons. Okay, what should come to your mind is covalent bond. Covalent bond, that is where sharing of electron occurs. But if you paraphrase this question and you see transfer of electron, it is going to be ionic bond. Okay, another way this question can come is they'll give you elements, they'll give you a particular element, and they'll tell you, or they'll just give you the electronic configuration of the element, and they'll tell you what is the bond formed. All right, there is a formula for you to know when metal and metal, or sorry, when non-metal plus metal react, the bond that forms there is a ionic bond. But when non-metal and non-metal react, it is covalent bond. Take note of that. So once you see the element, is it metal, is it non-metal? You see the two elements, then you know the bond. This is just a trick for you to know the bond. Number 17, the IUPAC name for this structure or this formula, we have done a video on nomenclature. So if you are preparing for UTME 2026 and then you are still struggling with nomenclature, it is important for you to go and check out that video because everything has been explained. Okay, so if you look at this particular structure here of formula, you see that it is expressed in a skeletal, in a condensed form, rather a condensed form. Most likely, all your questions are going to be condensed. You just see a few that will give you the normal skeletal structure where you used to have something like this and just put line and stuff like this. Okay, so now how do you do this? You already have OH, which means that this guy is an alcohol. So because it's an alcohol, it's going to be ending with O, right? So let's look at the options that end with O. If you look so well, you see that all the options end with O. So that is not enough for us to pick our answer. The next thing is to look for the parent carbon. How many carbons are here? 1, 2, 3, 3 carbons. And 3 is prop, prop, prop. So which option is that? So that's propanol, propanol. All right, question 18. Which gas is evolved when dilute HCl reacts with CaCO3? Okay, dilute HCl reacting with CaCO3 is a very common reaction. Okay, in chemistry, there are basic reactions that you should know and their products. For example, acid reacting with base, neutralization reaction. You know that it gives you salt and water, right? The same thing, acid reacting with triazocarbonate. If you look at this is a triazocarbonate, right? CaCO3 is a triazocarbonate. And once acid reacts with triazocarbonate, there's something that happens. Acid is formed, salt is formed, water is formed, and then CO2 is formed. Okay, so unlike acid and base is just salt and water, then acid and triazocarbonate is going to be salt, water, and carbon dioxide. Okay, so the correct answer is carbon dioxide, CO2. So this question can be paraphrased and it will give you another triazocarbonate. Just know it is still going to give you CO2. Alright, so the process of separation used to obtain pure water from seawater is known as distillation. So distillation removes dissolved salts, okay, because the water and seawater they already dissolve salt. So distillation is used to do that. All right. Number 20. Which law states that the total pressure of a mixture of non-reacting gases is the sum of their partial pressure? When you see anything relating to partial pressure and sum of partial pressure, and they're asking you which law is that, the answer to that question is Dalton's law of partial pressure. The Dalton's law of partial pressure states that total pressure of a mixture is equal to the sum of their partial pressure. Okay. 21. Methane belongs to which homologous series? It's a very simple question. Methane belongs to the alkane series. Alkane series. All right. Next question. In the reaction Zn plus 2HCl is equal to ZnCl2 plus H2, zinc is acting as. Now, when you see a question like this, if you come across a question like this and they tell you which one is the oxidizing agent, which one is the reducing agent, which process is oxidation, which process is reduction, take note. When you are looking at oxidizing and reducing agent, it is always in the reactant. Take note. It is always in the reactant. It's always in the reactant. So if they give you this equation and they tell you what's the oxidizing agent, what's the reducing agent, and they give you some option, you can streamline your answers to just two because you already know that it's in the reactant. And they will put zinc chloride and in the option, they will put hydrogen in the option, but it can never be the answer. It is always in this particular part in the reactant, except it is a reversible reaction. Then they now tell you backward reaction when it is going back. And that's when we can now say maybe this one can be considered. Okay. Now the question says which of the following is what is zinc acting at? Alright, what is zinc acting at? So now if you look at zinc, let's look at zinc. So zinc to zinc chloride. Something is happening. Zinc to zinc chloride. What is that? Zinc chloride is zinc firstly is losing electrons. All right, zinc is losing electrons. Now you might want to ask me now, how did I know that zinc is losing electrons? Now we said something earlier that the oxidizing state of an element or the oxidizing state of a compound is always zero, which means that the oxidizing state of this zinc here is zero. Now the oxidizing state of zinc in zinc chloride is plus 2. Now when zinc is 0 and when zinc is plus 2, hope you know this plus 2 means that zinc has lost 2 electrons. When you see zinc 2 plus in chemistry, it does not mean that 2 electrons has been added. It means that 2 electrons has been lost. So zinc to zinc chloride, that reaction is known as oxidation reaction. Okay, so the reaction here is oxidation reaction. Now, what is now the agent? Is it an oxidizing agent or a reducing agent? Take note, it is the opposite. So zinc is a reducing agent. So if the process is oxidation, the agent is going to be reducing agent. If the process is reduction, the agent is going to be oxidizing agent. It's as simple as that. Another trick you can use to know, in case you don't want to stress yourself, to just start. Once you see it is a metal, most likely it is a reducing agent. If you see it is a non-metal, most likely it's going to be an oxidizing agent. So once I just see this question and they ask me zinc is acting as what, I'll just ask myself, is zinc a metal or non-metal? It's a metal, right? So definitely it's going to be a reducing agent, right? But then I've given you the step-by-step explanation on how we concluded that it's a reducing agent. The empirical formula of a compound containing 40% carbon, 6.7% hydrogen, and then 53.3% oxygen is. So calculating for empirical formula is also a very simple calculation. Alright, so how do you calculate for? You should know the relative atomic masses of this element. So carbon is 12, so we divide this 40 by 12. Hydrogen is 1, we divide it by 1. Oxygen is 16, we divide by 16. Okay, so by the time we do this, we're going to be having about 3.33 here, 3.33 here. Then we're going to be having 6.7 here, 6.7 here, and we're going to be having 3.33 here, 3.33. So now, when you have this kind of, when you get to this stage, what you need to do is to divide by the smallest number. What is the smallest number? 3.33. So if you divide 3.33 by 3.33, we're going to have 1. 6.7 divided by 3.33, we're going to have 2, and this is going to be 1, which means that CHO is combining in the ratio 1:2:1, which means that this is going to be the formula. So now if you look at this, this is corresponding with B, CH2O. Alright, so the next question. Which of the following will turn blue litmus paper red? Blue litmus paper red. Now, when you see this question, you can even, if in fact, if you get confused with the example, you just get to the example and say, is it acid or is it base? Is it, with the option you can even know. If you look at this is a base. This guy is also acting as a base. This guy is also acting as a base. So we already have 3 bases in the option, which means that the answer is most likely going to be, it's not most likely, the answer is an acid, so HCl. Okay, so just for you not to mistake the mnemonics or mistake this litmus paper test, because sometimes you can mistake it, just remember the mnemonics ABR and BRB. ABR and BRB, like ABC, ABR. Okay, acid turn blue litmus paper red. Blue first, that is blue litmus paper red, and so we have HCl there. Okay, so 25. The standard for measuring relative atomic mass is based on which isotope? It is based on carbon 12. Carbon 12 is the standard reference, and that is why in the definition of relative atomic mass you see carbon 12 there. Okay, 26. According to Graham's law of diffusion, the rate of diffusion of the gas is inversely proportional to the square root of its vapor density. Okay, please take note of that. That's why you see this formula. We have rate, right? Rate is directly proportional to 1 over density. So you see something like this, 1 over density. This particular relationship is the Graham's law of diffusion. Alright. 27. Which of the following is a neutral oxide? Which of the following is a neutral oxide? So question that you should be expecting under oxide will tell you, is it acidic, is it neutral, is it basic? Okay. So neutral acid are basically neutral oxide rather are oxide that are neither acidic nor basic. Alright, and N2O is an example of a neutral oxide. An example of a neutral oxide. 28. The process of boiling an ester with an alkali to produce soap and alkanol is known as. Once you see produce soap, the process of production of soap is known as saponification. Option B, saponification. So the production of soap is known as saponification. So saponification is the correct answer. 29. What is the percentage of mass of nitrogen in ammonia nitrates? Okay, so it is very, very simple to calculate this. So what we just need to do is to know how many nitrogens are here. So we have 2 nitrogen, right? So we have N2. N2 divided by NH4 and then NO3 times 100 times 100. Then we get the percentage by mass. of nitrogen. Okay, N2, N has been given to us. Okay, so we have N to be 28 because N is 14, so N2 is going to be 28. So we have 28 divided by. Now let's calculate for NH4NO3. N is 14, right? H is 1, and we have 4H, that's 4. Then we have N again, that's 14. Then we have O, 16, but it's 3, which makes it 16 times 3, and that gives us 48, right? 48. So if we calculate this very well, 14 plus 14, 28, 28 plus 48, we have 76. Okay, 76 plus 4, that gives us 80, right? So we have 28 divided by 80 times 100. So if you do this very well, you get 35. So the percentage by mass of nitrogen is 35. Okay, 30. The bonding in sodium chloride, you can see now that question has come again. Sodium chloride bonding in sodium chloride is dash. Sodium is a metal, right? Chloride is a non-metal. Which bond is between metal and a non-metal? It is electrovalent bond. So I'm putting this ionic because you can see either electrovalent or you see a ionic bond. Okay. Number 31. Which of the following elements has the highest electronegativity? Alright, the correct answer is fluorine. Fluorine, when you get electronegativity, the most electronegative group in the periodic table is the group 7, which is the halogen. Alright, and there's something about periodicity. I've made crash course and summaries on all of these topics. Okay, so do well to access those crash course. I have dropped the links in the description of this video. So you can do that now or immediately after this video. Just do well to check out crash course under periodicity and periodic trend. I've summarized it and given a shortcut. If you check that space, you'll see that something decreases down the group, electronegativity decreases down the group. So which means that the elements in the top of the group will be more electronegative than those down. And in the halogen, fluorine is the one up. So fluorine is the most electronegative, or it has the highest electronegativity. Number 32, the cracking of petrol fractions is done to increase the yield of gasoline. It's done to increase the yield of gasoline. So cracking breaks large hydrocarbons into smaller and then more useful fuel like petrol. Okay, so it's to increase the yield of gasoline. Number 33, 200 centimeter cube of a gas at 25 degrees Celsius exerts a pressure of 700 millimeter mercury. What will be its volume at STP? Now, when you see a particular question like this, a lot of persons ask, what will be STP? Will STP be the P1 V1 T1 or the P2 V2 and then T2? Now, if you look at this particular question, you'll see that parameters were given first before they mentioned STP, right? Before they mentioned, so STP is the second, which means that STP is going to be the P2 V2 and then the T2. So this is going to be the STP. So what we're looking for is the V1. Do you understand? So, but now STP can be P1, V1, and T1 when STP comes in the beginning of the question. So take note, where is the STP coming? Is it the beginning or at the end? That will determine what you are going to calculate. Because trust me, if you don't get the parameters well, you will definitely get a wrong answer. And you know what? That wrong answer is going to be the option. Alright, so since we're looking for V1 or rather V2 because they have given us V1 already. So we're looking for V2. Where's my pen? Okay. Alright, V2. So this means that by the time we do the subject of formula V2, you know why it is V2? Because V1 has been given here. This is the first V1. So we're looking for V2. So V2 is subject of formula. We're going to get P1 V1 T2 divided by T1 and then P2. All these calculations, all these things are meant to be at your fingertips at this particular point in time because you'll be writing your UTME in very few days. The person who's going to be writing their UTME the last day just has about 4 days to UTME. So which means that you don't have so much time. So all these things should be your fingertips. So nobody should be so confused about how is V2 equals to P1 V1, T1 over T1, P2. Okay, so by the time you do all of those calculations, your P1 is 700, V1 is 200. It's already in the question. T2 is 25 degrees Celsius. But something you take note of is that you can't use 25 degrees, you can't use degrees Celsius to calculate. So you are converting it to Kelvin. And when you are converting it to Kelvin, what do? You add plus 273, right? 273 to it. That is going to be our that's going to be our T1. Okay, so T2, standard temperature. Remember that T2 is standard temperature. So standard temperature is going to be 273. So 273, that's standard temperature, 273 Kelvin. All right, so P1 700, V1 200, T2 is what? Standard temperature. Then T1 is this 25 degrees Celsius. Then you add 273. That should give us 298. Then our P2 standard pressure is 760 millimeter mercury. Okay, so by the time you do that, you will be arriving at an answer which is 168.7 centimeter cube. Okay, 34. Which of the following is an isotope of hydrogen? Isotope of hydrogen is deuterium. All right, so we have protium, deuterium, and tritium. Now, all of these are isotopes of hydrogen. Okay, so for deuterium has one neutron. Okay, one neutron. 35. The functional group COOH is characteristic of arachidonic acid. So arachidonic acid is also known as carboxylic acid. We said that they are also known as carboxylic acids. Okay. All right. Moving on. In the periodic table, elements in the same group have the same number of valence electrons. So if you have element A, B, and C, the reason why they are in the same group is because their valence electrons are the same. So you can have something like 2,1, 2,8,1, 2,8,8,1, 2,8,18,1. All of these elements you are seeing here, they are all in the same group. Why? Because their valence electron, the last electron here, is what? The same. 37. The gas that turns lime water milky. This is a very common question. When you see this question, you shouldn't even think twice. The answer is carbon dioxide. 38. How many electrons are present in the L shell of an atom of carbon? Alright, so you should know your shells. So for carbon has the electronic configuration of 2, 4. Right? 2, 4. And this is K shell. This is L shell. Which means that your carbon has 4 electrons in the L shell. Okay? 39. The catalyst used in the manufacture of tetraoxosulfate 6 acid, which is contact process, is your vanadium 5 oxide. Alright, so vanadium 5 oxide V2O5 is a catalyst used in the contact process. You should also know the Haber process, contact process and Haber process, everything about it. Which one is exo, which one is endo, the catalyst, the process, all those things you should know them. 40. The solubility of a gas in a liquid generally dash. Solubility of gas in a liquid generally dash. Okay, increases with increasing temperature. No, this is wrong. Okay. Option B, it decreases with increasing pressure. This is absolutely correct. This is absolutely correct. All right. Gases become less soluble as temperature increases. That is something that you should take note of. Okay. Question 41. Which of the following is an example of a chemical change? So when we talk about change, we have a chemical change and then we have a physical change. We already know that a chemical change is a particular change that cannot be reversed, while physical change is a change that can be reversed. Okay. So basically, this option we're looking for something that cannot be reversed. So when it happens, it has happened. It cannot be brought back. So A, melting of ice. Melting of ice is not chemical, it is physical because we can once the ice melts, we can still turn the liquid back to ice. So it is reversible. So it is physical and not chemical. Rusting of iron. Rusting of iron is the correct answer. Rusting of iron is a chemical process because once the iron rust, you can't get back the iron the way it was. Alright. Question 42. The shape of a water molecule is bent, V-shaped. Alright. Shape All right, so question 44. Which of the following will react with zinc to evolve hydrogen gas? Remember, in the production of hydrogen gas, there's something that happens that acid reacts with metals to produce hydrogen gas. So basically, what we're looking for in this option is an acid. Okay, so which of these is an acid? Definitely H2SO4. H2SO4 is the appropriate answer. Okay, 45. The separation of two or more mixable liquid with different boiling points is known as fractional distillation. This is a very common question. Fractional distillation separates liquids with close boiling point. All right, question 46. Which of the following is a property of an alkali? Property of an alkali. Remember that alkali are bases, okay? But the difference between alkali and just normal bases or just a base is that alkaline are soluble bases, which means that there are other bases that are not soluble. Okay, so alkaline are soluble bases. And one of the function or the property of a base is that they have a soapy feel. They have this kind of slippery like feel. Okay, take note of that. 47. The kinetic molecular theory of gases assumes that collision between gas molecule is perfectly elastic. Perfectly elastic. So it is perfectly elastic because no energy is lost during collision. So while the molecules are hitting themselves, hitting the container, there's no energy lost. There's no energy lost, which means that they are the condition is perfectly elastic. Okay, take note of that. 48. An example of a greenhouse gas is now, if you look at this now, you can see that there is no that your common greenhouse gas, which is CO2, is not here. Okay, because once you see greenhouse gas, where your mind will first of all go to is what? CO2, right? But you can see your CO2 is not here. The correct answer to this is methane. Methane is also a greenhouse gas because methane traps heat in the atmosphere. Okay, 49. The empirical formula of a hydrocarbon containing 85.7% carbon and then 14.3% hydrogen is what? So remember the step that you need to take, right? So you divide this by 12, that's the first step, and then you divide this by 1. So if you divide this by 12, let me bring this here. So if you divide this by 12, you are going to have 14, or rather, you are going to have 7.14, 7.14, and 14.3. So if you divide by the smallest, 7.14 or 7.14, mathematicians will say it's not 14, it is 14. So let me go with that. 7.14, 7.14. So by the time you do this, you're going to have 1 year and then 7 points. Approximately, this is going to be 2 by the time you do the calculation. So which means carbon is 1, hydrogen is 2, and this makes option B correct. Okay. Then we have question 50. Which of the following is the most abundant element in the Earth's crust? Abundant element is oxygen. Okay, oxygen makes up about 46% of the Earth crust. All right, so I've come to the end of this video on the JAM 2026 chemistry questions. All right, so please do well to indicate in the comment section if there's a particular question that you don't understand. And like I said previously, ensure that you practice more questions. Okay, this period is not a period that you should just keep on reading. Ensure you are practicing more questions. The more you practice more questions, the more you realize that there are some concepts you think you understand well that you don't understand well. And you know what practicing question does? Practicing question allows you to identify those areas that within you think you know those areas. But when you attempt question, you now see that, oh, I don't really know this thing. No. Okay. So in that light, I am going to be dropping more videos, more questions. Okay. Like I said, I've dropped my crash course link and my question bank link in the description of this video. Do well to access it and also anticipate the second part of this video. Those of you who are going to be writing biology, ensure you also check out the biology, and as much as possible, ensure you are sharing this video to your friends, your classmates, everybody that you know that is going to be writing UTME 2026. Okay, I wish every one of you who are going to be writing your exam in a few days time success. Okay, see you guys in the next video. Bye for now, guys.